Hello, hi, namaskar everyone. In this video, we'll discuss 5 quality problems asked by JEE Advanced, which we'll be solving with class 11 standard logic. Without any delay, let's get started with the first question. If you want these questions and their solutions in a PDF format, you can follow our WhatsApp channel. The link to our WhatsApp channel is given in the description. There, we'll be uploading this entire PDF. So the first question reads as, for a non-zero complex number Z, okay, argument of Z, we know argument of Z is principal argument. We know that. We know this property as well, that argument of Z, we keep it between minus pi to pi. Now, what are we told next? Omega is the cube root of unity. Okay, that is also something very interesting they have told, for which we know that argument of omega is between 0 to pi, which means it is your minus 1 plus root 3 iota by 2. It is not minus 1 minus root 3 iota by 2. I hope you remember that. Now, they are telling you that there is an expression alpha which is defined by this expression. Then they are asking you the value of 3 alpha as the value of 3 alpha by pi. Okay, so let me start working on this alpha. How do we work it out? Let's figure it out. So what is alpha? Alpha is argument of something. So argument I'll work out later. Shall I work on this expression? What is this expression? This is summation n is starting from 1 to reaching till 2025, and it is minus omega to the power n. Okay, so let's say if I simplify this, how does it look like? N when placed as 1, 2, 3, 4, 5, I'll get minus omega to the power 1, then plus minus omega square, I'll keep it as minus omega square only, then plus minus omega cube, and so on until what? The last term, which is minus omega to the power what? 2025. Now, can you all help me with a very basic discussion here? Is it not looking like a GP? Minus omega multiplied with minus omega square, then minus omega cube, and so on. And for a GP, I hope this is what you study in sequence and series, that sum of a GP of n terms is given by A times r to the power n minus 1 divided by r minus 1. Yes or no? Although it can be 1 minus r to the power n upon 1 minus r, vice versa. It depends, because minus sign, if you take common from the numerator and denominator, the formula remains same, or it simply changes to what you might have seen. So with this, I hope you remember here. What is your A here? Sir, first term is minus omega. What is common ratio here? Luckily, that also is minus omega. And number of terms, I'll say 1 to 2025. So number of terms will be 2025. So I think we have the formula. I'll simply apply this and get my answer most probably with the next few steps. How do we get that? Let's start working on that. So here, I'll say Sn. So Sn here will be given by A. What is A? Sir, A is minus omega times r to the power n. What is r? Sir, it is minus omega to the power n. What is n? The number of terms, which is 2025. Minus 1, right? Then whole divided by r minus 1. What is r? Sir, r is minus omega, so it is minus omega minus 1. Yes or no? Everybody got that? Now from here, what I do is, I hope you remember that omega cube is 1. Do we know that? So if omega cube is 1, tell me 2025. 2 plus 5, that is 7 plus 2, 9. So 2025 is divisible by 3. Sum of digits is 9. So this minus omega cube, I hope you're understanding, even if it is minus omega, it is an odd power here. So even if I take this minus sign out of this, I hope you are realizing I can write it as omega to the power 2025 because of odd power and a minus outside. With this, what have we received? Sir, we have attained, this is omega to the power 2025. 2025 is a multiple of 3. That means this is omega cube whole raised to the power some integer, which means omega cube is 1. So this is 1 raised to the power some integer, which is 1. So it is minus 1 minus 1. That yields what? Minus 2. I hope you're getting it. So minus 2 into minus omega, that is plus 2 omega. Yes or no? Whole divided by omega plus 1. And when I take a negative sign common out, can I write it like this? All I have done is, this was minus 1, minus 1, minus 2 into minus omega, made it 2 omega. But when I took negative common out from this minus 1 and minus omega, it became 1 plus omega, and minus stayed in the numerator. Now, we know one more property which most of you must have studied, that 1 plus omega square is always 0. So from here, 1 plus omega can be substituted by minus omega square. So this I can replace by minus 2 omega whole divided by what? Minus omega square. Yes or no, everyone? Give me a quick update. Did you all get that? And I think with that, we have a very good and decent result, that this minus and minus are cancelled, 2 stays there, and we are left with 1 upon omega, or rather 2 upon omega. So I am now finally left with 2 upon omega. That's my final simplified version of this expression, but we need the argument of it. So we need the argument of it, that will be alpha. But I'll say that instead of finding argument of it, shall I multiply it by omega square in the numerator and denominator? So it will be 2 omega square in the numerator, omega square into omega, that is omega cube in the denominator. So technically we need to find the argument of 2 omega square. So I hope you understand, whatever is the argument of omega square, that will be the argument of 2 omega square, 5 omega square, 6 omega square. So this 2 doesn't matter. So I hope even if you plot it on the Argand plane, I hope you know that these cube roots of unity 1, omega and omega square form an equilateral triangle. So you see 1 placed here, you see omega placed here, and you see omega square placed here. And I hope you remember this clearly forms an equilateral triangle. Now what are we asked? We are asked the argument of omega square or 2 omega square, which is going to be same. I hope I need not tell you. For this omega, we know it is 120 degree. So for this omega square, it is minus 120 degree. Do you remember that, everybody? So with this minus 120 degree, I hope you understand how do we, or what do we mean by argument. Argument means if I join this omega square with origin, this angle here, minus pi to pi. So had it been in the first or second quadrant, 0 to pi. But if it is in the third or fourth quadrant, minus pi to 0. I hope you remember that. So with that, it is minus 120 degree. Minus 120 degree means what? It is minus 120 degree, but it is of course in radians. So if I get back to this is 3 alpha by pi. So here it is 120, which is of course your 120 is 120, double of 60. Yes or no? Everybody, 120, 120, 120, that is 360. I hope you remember that. Everybody clear with the basics of cube roots of unity? How do we plot it in the Argand plane? All of those basics I'm not covering here. So with that, if it is 120 degree, I hope you know that 60 degree is pi by 3. So it is 2 pi by 3. So we have finally gotten the value of alpha as 2 pi by 3. But what are we asked? We are asked 3 alpha by pi. So if we have cracked, where shall I write it? This is your alpha, which is 2 pi by 3, right? So 3 alpha by 2, I think this is what we are asked, 3 alpha by pi. So this will be 3 alpha by pi, that I think is nothing but 2 if you just rearrange it. And that's your answer. Everybody got that? I hope this was absolutely easy, which you all should have done if you attempt it or see it in the paper. Let's move towards the next question. This is a question asked by JEE Advanced from the chapter Sequence and Series. So yes, again, this is something which most of you could have done. How do we do it, or how do we solve this? Let's pay attention on this. R denote the set of all real numbers. So it uses one silly concept from the chapter Relations and Functions that also you might have seen previously if you were preparing for IIT-JEE in 11th standard only. So this function gives you fr to r. It is a function such that f of x is always positive. Okay, f of x is said to be always positive for all x which are real, and they are telling you that f of x plus y is equals to f of x into f of y. Now, if f of x is always positive for all x which are real, and if it is satisfying this, now just pay attention to this pattern here. Have you not noticed something like this, sir, that a to the power x into a to the power y is always a to the power x plus y? Yes or no? Yes or no? This we know from indices, right? Now with that, I hope you're noticing, if I call a to the power x to be f of x for a while, just to make you understand, is it not f of x? Is it not f of y? And with that, is it not f of x plus y? Yes or no? Give me a quick update on that. Are you all digesting this? This is your f of x plus y, f of x, f of y. I think so here it's wise and advised that I can take f of x as a to the power x. Although a is taken already or reserved by them as a1, a2, a3, so it's better that I take it as b to the power x. I hope b is not used by them. So I'm here taking f of x as b to the power x. And yes, it fulfills that condition, that f of x is clearly greater than 0. So that assumption I'm proceeding with. Now, what are we told? Then the second part of this question, which uses the concept of 11th standard, although this part was a little bit of 12th, but I hope with basic logic, you could have cracked it as b to the power x. Are you all getting this? Absolutely doable. With this, what am I told next? Let the real numbers, so a1, a2, a3, a50, they all are real numbers and they all are forming an AP. So they are in AP. Okay, that's good. And I am told f of a31 is equal to 64 times f of a25. Now look at this. We know one very interesting property that if terms are in AP and if you take them to exponents, then they get converted into a GP. Let me set the reverse of it. I hope you must have studied this property in sequence and series, that let's say if terms are in GP, if a sequence is there given in GP. And if you take logarithm of all of these terms, of course they should be positive. So if you take logarithm of all of these terms, they'll be get converted into an AP. So if you take NT-log, I hope you're understanding, if terms are in AP and if you raise them to a certain base, a fixed base, then they all will get converted into a GP. If you did not understand my words, I'll simply say this, that here, let's say I have terms. Let's say I have terms. Which terms? Let's say I'm writing them as M1, M2, M3, right? These are the terms and they are in GP. And I hope you remember, if I take log of them, so log M1, log M2, they all form an AP. Do you remember that? And vice versa is also true. Vice versa means what? Let's say there are terms. Terms means say T1, T2, T3. They all are in AP. They all are in AP. And I'm raising them to a certain power, a fixed number. Let's say positive number A. So A to the power T1, A to the power T2, A to the power T3. And this will be forming a GP. Exact a reverse process of this. So this is a property which I'll be using here. Although if you don't know this, you would get this result by default if you start solving it. But if you're aware of it, it will actually, increase your ease of doing it. So this property, if I apply here, f of A31. So first of all, this is an AP. For this AP, I'm assuming that the common difference is D. So I'm taking, let's say, the common difference here is D. I hope I can take it like this. So common difference, if I assume as D. So any term, let's say nth term, if I wish to write, it will be A plus n minus 1 into D. So A is A1, the first term is A1. So with that f of A31, will you not say that if I write it, f of A31 will be f of x is b to the power x. So this will be b to the power A31, yes or no? X is replaced by A31 is equal to 64 times, is equal to 64 times f of A25. So it is clearly again b to the power A25, yes or no? This is b to the power A25. Now, sir, what have you attained by doing this? Is it really helpful? Trust me, it is indeed very much. How? Let's have a look at that. So A31 can I write as, of course, B A25 I can bring here. So this is B A31 minus A25, because if base is same and if you're dividing them, powers are subtracted, and this leaves you with the 64 here. Now, A31 and A25, can I do it separately? So if I do it separately here, how will you write it? A31 and A25, right? So A31 will be A first term plus n minus 1, 31 minus 1 is 30, D, common difference I'm taking as D, minus A25, that is first term A1 plus, but because of this minus it is minus 25 minus 1, that is 24D. I hope you are noticing A1 are cancelled, 30D, 24D, that leaves you with a 6D. So this is B to the power 6D, which is 64. I hope you know that 64 is 2 to the power 6, yes or no? 64 we all know is 2 to the power 6. So this b to the power d whole raised to the power 6 can be compared with 2 to the power 6. And with that, I can directly conclude that b to the power d will be 2. That's a very valid and insightful conclusion which we have released. I am saying that this b to the power d is actually nothing but your common ratio of the GP. I repeat, f of x, which is b to the power x. So if I'm taking f of x with these a1, a2, a3, so f of x means b to the power a1, b to the power a2, b to the power a3, and so on. These terms will be in GP. I hope you remember the property that if a1, a2, a3 are in AP, then b to the power a1, b to the power a2, b to the power a3 will be in GP. So that's same thing I'm saying here. And with that, this b to the power d will be the common ratio here. If you didn't get anything at all, forget right now. Just understand whatever I've explained so far till this step where I have concluded b to the power d as 2. Even if you don't get this idea, then also it is fine. It is absolutely doable. Just follow what is said. So far I'm able to conclude b to the power d as 2, which I'm taking as r. If you're not able to get that, forget that. Just keep b to the power d as 2. That is also doable. With this, the next portion says that summation of this expression. Summation of this expression. So this expression is looking something interesting here. Let's try and crack it. Okay. So with this, let me remove this particular part. I hope you all are okay with that. I'll be using some information here, but let me move ahead with this data, which we are told to be like this. F of A1, AI from I1 to 50 is 3 times 2 to the power 25 plus 1. What does it mean? Let me write this left hand side. It means f of what? F of A1 plus f of A2 till what? Till f of A50. Yes or no? I hope now something must be there. What is f of a1? Sir, f of a1 will be b to the power a1, f of a2 will be b to the power a2, f of a3 will be b to the power a3, and so on until f of a50, which is b to the power a50. Yes or no, everyone? Now, this is exactly what I'm telling you, that this is a GP. If you're still not able to notice it, I'll highlight it with a very simple observation that what is A1? Sir, A1 is A1, but what is A2? Sir, A2 is A1 plus D. What is A3? Sir, A3 is A plus 2D, and so on until what is A50? Sir, A50 is A1 plus, of course, this is A1 here, A1 plus 49D. Yes or no, everyone? Now, with the properties of indices only, although you should have noticed it that it's a GP, but if you're still not able to notice it, I'm solving it in a more simpler manner. B to the power A1, can I not take common? So if I'm taking B to the power A1 common, I hope now everybody is noticing, everybody is clearly noticing one simple fact here. I hope you all are there, that here it b to the power a1 becomes 1 plus this leaves you with b to the power d, this leaves you with b to the power 2d, and so on until the last term, which is b to the power 49d. So there are 50 terms. Now, are you not able to digest? Keep this outside. Even if had you kept it inside also, then also it was doable. But if you keep it outside, it is clearly visible. 1 into b to the power d is b to the power d. B to the power d into b to the power d is b to the power 2d. B to the power 2d into b to the power d is b to the power 3d. So is it not a GP? Is that clearly not a GP? And do we know how to find the sum of n terms of a GP? I think we have just discussed that, have we not? So if I apply that conclusion here on this LHS, I think I'll be in a better position to reach to a better simplified version of this LHS. What does it say? B to the power A1 stays outside. I cannot do much about that. Then A. What is A? Sir, A is first term, 1. R to the power n. What is R? Sir, R is b to the power d whole raised to the power n. What is n? So number of terms, which is 50 minus 1 divided by R minus 1. So what is R? R is b to the power d minus 1. So that's the simplified version of the LHS which you get. But what are we given on the RHS? Sir, RHS is saying something else. RHS said to be this, which I'll write later. Let me try and simplify this result where I know one thing. Which thing, sir? I know that b to the power d, I think I had cracked it somewhere, was 2. So b to the power d we have cracked as 2. So if I replace it by 2 in the numerator, this is b to the power a1, of which I cannot do much. But this is what? 2. So 2 to the power 50. So this is 2 to the power 50 minus 1 whole divided by 2 minus 1. B to the power d is 2. So 2 minus 1 is 1. So I don't have to write it. Everybody got this? Now this 2 to the power 50, can I write or can I not write as this b to the power a1 stays outside? 2 to the power 50 I'm writing as 2 to the power 25 whole square minus 1. Can I do so? Everybody give me a quick response. Can we do that? Sir, why did you do this? I am seeing a square minus b square here. Are you seeing that? A square minus b square. So this gets simplified as b to the power a1 staying outside. Then a plus b into a minus b. So what is a plus b? Sir, a plus b is 2 to the power 25 plus 1 into 2 to the power 25 minus 1. Yes or no, everyone? Give me a quick update. This is your expression, the simplified version of this. Everyone comfortably understanding all what is said so far is equal to what? It is equal to this. What is it? It is 3 times 2 to the power 25 plus 1. Sir, what have you attained by doing so? Trust me, I have gotten a very insightful and a very beautiful result, which says that, sir, this 2 to the power 25 plus 1 gets cancelled by this. So ultimately, you get b to the power a1 as 3 by this. So I think I have cracked one more information here. Shall I write that here? I have cracked b to the power a1 as 3 divided by 2 to the power 25 minus 1. So we have received as 3 divided by 2 to the power 25 minus 1. Sir, why are you putting so much efforts in doing all of this? Because I am now supposed to close this question with this final step. What is this final step saying? The final step now says that here you're supposed to figure out summation of f of ai, where I is from 6 to 30. 6 to 30 means what? 6 to 30 means here you're taking it as a6 plus a7. Sorry, I'm really sorry. You're taking f of a6 plus f of a7, right? Till what? Till f of a30. f of a30? Yes or no? How many terms they are? I hope you're realizing 30 minus 6 is 24 plus 1, 25. So there are 25 terms. So this I'll be writing as b to the power. I hope you remember f of x was b to the power x. So f of a6 will be b to the power a6. This will be b to the power a7. The next term will be b to the power a8 and so on until b to the power a30. Sir, what is the point of doing all this? Have patience. This b to the power a6 can I write as a1 plus 5d. This b to the power a7 can I write as b to the power a1 plus, I hope you're paying attention, as 6d. I hope you're noticing it now. This b to the power a8 can I write as b to the power a1 plus 7d and so on until b to the power a30 can I write as b to the power a1 plus 29d, because a1, a2, a3 are in AP, so I can do so. Everybody with me on this? Now with that, what am I getting now? I hope you are getting a conclusion. Let's say you can take a1 plus 5d, b to the power a1 plus 5d common. If you are doing so, if you let's say take this b to the power a1 plus 5d common, although you don't, even if you don't, that is also fine, but it will look more simpler to you. So b to the power a1 plus 5d, if I take common, it is 1. Then it is b to the power, I hope you're realizing d, because a1 plus 5d plus d, so it is b to the power d. The next term will be b to the power 2d and so on and so on. So if you have taken 5d common from 29, I hope you subtract 29, 5 from 29, and then you write the next term, but you don't have to do it. I'll say here, these are how many terms? So they are 25 terms, and they are again in GP. So if they are again in GP, do we not know how to find the sum? So it is b to the power a1 plus 5d. So can I write it as b to the power a1 into b to the power 5d, and b to the power 5d can I write as b to the power d whole raised to the power 5. Everyone comfortable with the simplification of this? Then this is again a GP. A is 1 into r to the power n. R is again b to the power d. So b to the power d raised to the power n. So this time n is 25 minus 1 divided by r minus 1, which is b to the power d minus 1. Give me a quick update on this. Everyone comfortably understanding this? Sir, what is the point of doing all this? I think I am going to write the answer in the next 1 or 2 steps. How? B to the power d, I think we have already cracked, was 2, I think. Yes, it was 2. So this b to the power d, if I replace by 2, this 2 minus 1 will be 1. So I need not write it. So in the numerator, it is b to the power a1. What is b to the power a1? B to the power a1 was 3 by 2 to the power 25 minus 1. So this is 3 by 2 to the power 25 minus 1. This is your b to the power a1. B to the power d is what? 2. So this is 2 to the power 5. So this is 2 to the power 5. Yes or no? Into b to the power d, which is again 2. So it is 2 to the power 25 minus 1. Yes or no? And this is 2 minus 1, which is 1. So I don't have to write it. And with this and this are cancelled. 2 to the power 5 is 32. 32 into 3 is, I think, 32 into 3, right? So it's 96. Yes or no? So my answer here to this question will be 96. I hope it was easy, it was doable, it was understandable, and you all have gotten the logic behind this. It was absolutely a good question, a very good question from sequence and series, which has been merged with basics of functional definitions, functional equations, but I hope you knew it, you understood it. One more question from 11th standard logic, if I were to solve from JEE Advanced, this is that question which says value of this expression. I'll say, just simplify this. Just look at this expression here. What do I mean by looking at this expression? I hope, first of all, if I do this, log of 9 base 2. This is your log of 9 at base 2. I hope you're comfortably getting this. Here, if I write this particular part, I hope you're getting this. This is 2 here. This is 1 by this. So I hope you remember this property. If I make you recall this property, 1 upon log b base a. So if you want to take in the numerator, it can be written as log a base b. The values of these two b and a are swapped like this. So, sir, why are you telling us this logic here? Because I am wanting you to understand, keep this 2 here like that only. But here, look at this. Log of 9 base 2 at base 2. So if I'm taking it in the numerator, this 9 base 2 becomes base, log of 9 base 2 becomes base, and this 2 goes there. So it becomes log of 2 at base log of 9 base 2. Yes or no? Did you all get this, or shall I repeat it? 1 upon log b base a is log a base b. So it is log a base b. Have you gotten that? Now I hope you remember this property as well. If you are given a to the power log b base a, then I hope you remember the value is directly written as b. Do you remember that property? So with that property being used here in this question, first of all, I hope I can take this 2 as power of 2. Are you comfortably getting this? So this is log of, pay attention to this part. This is log of, I hope there is no confusion on whatever I've done so far. All the participants comfortably getting whatever I've done so far. So this is log of 9 base 2 whole raised to the power log of something at a certain base. I repeat, I'll make you recall this property so that you can see the resemblance. A to the power log of b base a. I hope you remember. So let's say this is a. This is log of b. Then this is again a. So a to the power log of b base a is always your b. Do you remember that? So this final portion, this first part of your question, this is a, this is a. So log of b base a is whole raised to the power a. So here I'll be left with b only, which is 2 square. So my answer will be 4 from the first part. Did you all get this, or shall I re-explain this? Give me a quick update. Two simple straightforward properties I have used. The same logic I'll apply in the second part. I'll apply it now, although I should have done it firstly instead of doing this, because the same thing I'll be doing here in the second part, the same steps. First of all, this is under root 7, which I can write as 7 to the power 1 by 2. Can I do so? And with that, 1 upon log 7 base 4. Can I not write it as log of 4 base 7? Do you remember that idea? 1 upon log b base a is log a base b. That's exactly what I've done. And I hope you understand this 1 by 2 I can directly multiply to this log, because log, I hope here, this is what I can do here. This is what I can clearly do here. So this is 7 to the power whole of 1 by 2 times log of 4 base 7. A to the power m whole raised to the power n is a to the power mn. Now, n log m is log m to the power n. So this 1 by 2 can be raised there as a power of 4. So this will be log of 7 is to the power log of 4 base 7 raised to the power 1 by 2. Now, can you help me with 4's square root? That's 2. So this will get replaced by 2. Yes or no, everyone? Now, again, I'm using the same property. A to the power log b base a. So if this 7 and 7 are same, the value will be 2 here, and 4 into 2 is clearly 8. Was it not absolutely easy, which you all could have done? If you still got confused with the first part, just watch this part first and then re-watch this part, and then you'll get complete clarity. The kind of steps or the kind of formulae or the kind of logic I'm applying here in the second part, the same idea you're supposed to apply in the first part, and you will get it. You will definitely get it. With that, if I could move ahead with the next question, a brilliant one, an amazing one, a very insightful one. It will give you a lot of clarity. What does it say? It says G is a circle of radius r. Okay. G1, G2, Gn be the n circles. So first of all, there is a circle G which has radius r, and G1, G2, Gn are also circle of equal radii, which is given by small r. What am I told? That each of these G1, G2, G3, these n circles touch each other. So they are touching each other. Sorry, they touch this circle G externally. Okay, so this circle capital G is touched by all of these G1, G2, Gn. And for I, 1 to n minus 1, Gi touches Gi plus 1. Sir, what is the meaning of this line? And that happens externally. So this is happening externally. Okay, let me talk about this part first of all. Let's say I take I as 1. So if I take I as 1, what does it mean? I hope you're understanding. Gi touches Gi plus 1. So if I is 1, Gi, which means G1 will touch G2 externally. Getting it or not, everyone? Let's say if I take I as 2, then G2 will touch G3, G3 will touch G4, and so on, and that touch happens externally. Got my point? With this, if I now start defining this, and of course, Gn touches G1 externally. Okay, that's brilliant part. That's again one more extended version of it. Now, if I simplify this whole figure in a simple standard result or conclusion, what will I get with that is this. Pay attention to this part. First of all, there is this circle G. First of all, there is this circle G. This is your bigger circle. And there are smaller circles. So if this is your bigger circles, there are smaller circles. And these circles are touching this circle. So these circles are touching this circle. So they all are touching each other externally. And they all are touching this circle like this externally. I repeat, all I'm trying to make you understand is a simple fact here is this, that this is your capital G. This is your capital G, which has capital R as its radius. This is your G1, this is your G2, this is your G3. They all are of same size because they have the same radii, small r. and they all touch this capital G externally. So this is how all these G4, G35, Gn will be drawn, although they can be, this n is not fixed, so I'm keeping it variable, so there can be multiple circles. But still I know one thing for sure, that let's say if I choose the center of this circle, if I choose the center of this circle, so what do I get? I get something very beautiful and insightful. Let's say I join the centers of these two circles. Can I do so? Can I do so? Similarly, let me stretch it further by joining this center circle with this circle center and this circle center with this circle center. I think I'll get a triangle. Yes, you will get a triangle. Where will you not say that this length here will be capital R, this length here will be small r, this length here will be small r, this length here will be small r? Yes or no? That is absolutely understandable. With this, I am telling you one more fact here, if you are paying attention to this. If by using the symmetry, if I join this, by symmetry, I'll say these two triangles are absolutely congruent and this line will be the angle bisector, median and all. With that here, I'll say that if I ask you this entire angle, what would that be? Sir, there are n circles around it. I hope you're understanding. So with I hope you're understanding, I am getting this triangle. So if the whole angle is 2 pi, this one angle will be 2 pi by n. But if I ask you this angle over here, will you not say it will be half of 2 pi by n? So this angle here will be pi by n. This angle here will be pi by n. Everybody give me a quick update on this. Are you all able to digest this fact? The complete revolution is of 360 degree, 2 pi. N triangles will get created, 2 pi by n. So one angle here will be 2 pi by n. But I'm taking half of it. It is angle bisector here. So it will be 2 pi by n by 2. So that's pi by n. Everybody got this idea. Now I am asking you to help me with one conclusion, which is this, that can you help me in writing sine pi by n? Sir, why are you doing this? Because I know two things. Which two things? With respect to this angle, I know the side opposite to it and the hypotenuse. So perpendicular and hypotenuse, I can deal with sine. So this is perpendicular r by small r plus r. So this is small r by small r plus r. Yes or no? Can I do so? Everyone with me on this, whatever I've done so far. All I'm saying is perpendicular upon hypotenuse r plus r, small r plus capital R. Now, if in order to simplify this, if I take reciprocal on both these sides, what do I get? If I'm taking reciprocal on both these sides. So here, I'll say sine pi by n's reciprocal is what? Cosec. So this is cosec pi by n. And here what will I get? R plus r by r. So r and r are cancelled. This is 1 plus r by r. Yes or no? Everybody with me on this? So there, if I wish to define it as, if I take this one on the left hand side, it becomes -1. So cosec pi by n minus 1 is capital R by r. And there, capital R, if I wish to write, will I not be writing capital R as, pay attention to this part, small r times cosec pi by n minus 1. I hope everybody got this. I repeat, capital R will be small r times cosec pi by n minus 1. So that's a conclusion which I've got it. Now I'll start applying options, because this is an MSQ, multiple select questions, more than one options are correct. So if I go ahead with option 1, what is option 1 saying? This is your option 1. If n is 4, then r is greater than root 2 minus 1 times r. Okay. So if n is 4, that means if there are only 4 circles around it. So if n is 4, let me replace n as 4 here. So this will be for option A. For option A, capital R is equal to small r times cosec pi by 4, because n is 4. Cosec pi by 4, sine pi by 4 is 1 by root 2. So cosec pi by 4 is reciprocal of it. So it is root 2 minus 1. What are they saying? That capital R is greater than root 2 minus 1 times r. No, it is equal. It is equal, right? So I hope we can clearly say option A is wrong. Option A can be discarded. Did you all get the logic? Now, can we move ahead with option B now? I hope you are comfortably getting it. How are we approaching it? So now, if I solve it for option B now, hold on for a while, students. If I solve it for option B, so option B says if n is 5. So if n is 5, will I not say capital R will be given by r cosec pi by 5 minus 1? Yes or no? And then there is again a relation between small r and capital R. Pi by 5, I don't know its exact value, but can we do some approximation here? Can you help me with pi by 5? I hope you remember, pi we all know is 180 degree. So I'm asking you to find pi by 5. So if I do this 2 by 2 here, this is 2 by 5. So it is 360 by 10, which is 36 degree. So sir, pi by 5 is clearly 36. Now, what are we interested in? Sir, we are interested in cosec pi by 5. Okay. Now, let me help you with this. sine 30 degree and sine 36 degree. Can you give me a conclusion here? I hope you remember the graph of sine theta is clearly like this between 0 to 90. This is 0, this is 90 degree. So between 30 and 36, this is clearly an increasing function. So sine 36 will be greater than sine 30. But cosec is reciprocal of it, which means if you are taking reciprocal on both the sides, it will be reversed. The sign will be changed, which means here, if I say what is cosec 30, you will say, sir, it will be greater than cosec 36. Yes or no? Everyone got my logic here? Everyone understood what I'm trying to build here? So with that, can you help me with sine 30? Sir, it is 1 by 2. Cosec 30 will be 2. So 2 is greater than cosec 36, which of course is your cosec pi by 5. I hope there is no confusion on that. With this, if I subtract 1 on both these sides to create something like option B. So if I subtract 1 on both these sides, of course, 2 minus 1 is clearly 1. I hope you got this. Now, one thing I'm going to do is, I'll multiply both these sides by small r. So if I multiply both these sides by small r, this gets r and this also gets r. But what I know is that, sir, r times cosec pi by 5 minus 1 is r. Capital R, that's what I know. So this whole value is capital R. So I got capital R to be less than small r. I got capital R to be less than small r. Are we given capital R to be less than small r? No. So option A, option B, both are wrong. Everybody understood this logic? Can I move ahead from here, all the participants from here? Then the next thing which we build here is the next option. The next option is option C. So let me move ahead with option C now. I hope everyone is comfortable with whatever is being done. Option C says if n is 8. So if n is 8, what do we get? What do we get? We get capital R as r times cosec pi by 8. Everyone getting this? Minus 1. Now, what is pi by 8? Let me try and work it out. So here I'll say pi by 4 is 45. So pi by 8 is 22.5. So again, I'll say that can you help me in cracking the code here? Cosec pi by 8 and cosec pi by 4. First of all, we know cosec is a decreasing function, reciprocal of sine. So this is 45 degree. This is 22.5 degree. So cosec 45 will be less than cosec 22.5. Yes or no? Everybody with me on this. Now with that, do we know cosec 45? I hope you know. Sine 45 is 1 by root 2. So this should be root 2. So this here can be replaced by root 2. Yes or no? Now cosec pi by 8. I am subtracting 1 from both these sides. So if I subtract 1 from here, this 1 can be subtracted from this side as well. Now if I multiply both these sides by small r, what do I get? Sir, I get this multiplied by r like this. This also getting multiplied by r like this. Everyone getting this? But this r times cosec pi by 8 minus 1 is nothing but capital R. So this value here can be substituted by capital R. Yes or no? So what I got was capital R is greater than root 2 minus 1 times r. So I think option C is correct. So option A and B are incorrect. Option C is correct. Let's check it for option D now. I hope everyone is comfortably understanding how are we solving these questions. So now I'm going to check it for option D. If n is 12, okay, so if n is 12, what happens? Let's talk about that result as well. If n is 12, so r will be, for option D, r will be given by r times cosec pi by 12 minus 1. Yes or no? Now let me talk about pi by 12 here. If you are confused with pi by 12, I hope you know this value. Pi by 12, pi is your 180 degree by 12. I hope you know these values. If you don't, this is how you do it. This is 12's 15 times, because 12's 10 times is 120 plus 60 is 180. So this is clearly your 15 degree. So to work out something related to 15 degree, I hope you remember it can be written as 45 minus 30. Although these values you should know if you are preparing for JEE Advanced, but if you are getting confused, you can work it out in a very simple manner. I'm going to deal with cosec. So let me try and find sine 15. Although you should know its value, but if you ever get confused, you use this method. You write it as sine 45 minus 30. Sine A minus B, sine A cos B minus cos A sine B. Sine A cos B, sine 45 cos 30. So 1 by root 2, root 3 by 2. So this will be root 3 by 2 root 2. Yes or no? Minus, I hope you remember, cos 45 sine 30. So this is 1 by root 2, 1 by 2. So that is 1 by 2 root 2. So I hope you are getting it. It will be root 3 minus 1 by 2 root 2. So that we have received as the value of sine pi by 12. So reciprocal of it will be this 2 root 2 by root 3 minus 1. So cosec 15, if I were to ask you, cosec 15 degree, if I were to ask you, you would have said, sir, it will be 2 root 2 divided by root 3 minus 1. Everyone comfortable with that? Shall I rationalize it? So if I wish to rationalize it, what will I get? Sir, you are supposed to multiply it by root 3 plus 1 in the numerator and the same root 3 plus 1 in the denominator. With that, this will be 3 minus 1, which is 2. 2 and 2 are cancelled. So ultimately, you get it as root 2 times root 3 plus 1. That is the value of cosec 15 degree, although you should know these values. Now, let me try and work out the result at this stage. So what I get is, this is capital R. Capital R is equal to small r times cosec pi by 12. I think cosec pi by 12 we have just cracked as root 2 times root 3 plus 1. So this will be root 2 times whole of root 3 plus 1 minus 1. If minus 1, if I multiply with this small r, I hope it can be placed like this. Everyone getting this? Now, I am trying to see a result or a conclusion here, which is a very beautiful result, that if I bring this r on the left hand side, so can I do this minus r? If I push from here to this side, this will be capital R plus r is equal to this. Now pay attention to this part. Everyone, stick to this part. This will give you the whole conclusion very amazingly and beautifully. What is that? Pay attention to this. This is your r times, small r times root 2 times root 3 plus 1. So this is your this part. And this part is said to be greater than capital R. I hope you're understanding. This part is already capital R plus something positive. So will it definitely not be greater than capital R? I hope you understood my language. I repeat, this value is capital R plus something. So if this value I'm attaining by adding something positive to capital R, which means this value will definitely be greater than capital R. And I think that's exactly what we are told. So option D and option C are correct. Option B and option A are incorrect. Everybody understood that logic? Shall I move ahead from here, all the participants? With that, I will now move towards the next question, the final question for the day. Here we are. A number is chosen at random from the set. So this is a question from probability. Again, a question asked by JEE Advanced. So randomly chosen number from this set 1 to 2000. P is the probability that the chosen number is a multiple of 3 or 7. Can you believe that? Can you believe that? This is the question. So I am asking you, the numbers which are divisible by 3 will be 2000 by 3. I hope you're getting it. So the numbers which are, of course, GIF of 2000 by 3, right? So the numbers which are divisible by 3 will be these. I hope you're understanding my language very clearly. So when 2000 is divided by 3, I hope you understand 3 into 6 is 18. You're left with remainder 2, that is 20. That is again 6. Then you're left with 1. I'm really sorry. Then you're again left with 2, which is 20. So this is 6. So 666 point something. That means total 666 will be the numbers which will be divisible by 3. Yes or no? Are you all able to develop that logic? Similarly, if I ask you the numbers which are divisible by 7, so I'm asking you the numbers which are divisible by 7, you will say again 2000 should be divided by 7. Yes or no? I hope there is no confusion on that. So far, whatever I've done. With that, I hope you are getting it. 7 into 3 is 21, so 7 into 2 is 14. I'm left with remainder as 6. This is 60. 7 into 7 is 49. And 7 into 8 is 56. So 8 is 56. I think this was 60. So I'm left with remainder as 4. So I'm left with 40. So 40 means what? 7 into 6 is 42. 7 into 5 is 35. With that, 40 minus 5 is 5. So remainder is 5. But I'm left with 285 numbers. So in these numbers, 285 will be the numbers which will be divisible by 7. Now, if I say the numbers which are divisible by either 3 or 7, will you say that this plus this will be the answer? I think in that case, you are forgetting one concept from set theory, which we have learned, that if you are concluding or including some numbers and including some numbers here, you might be adding those numbers which are divisible by 3 and 7 both twice, here and here both. I hope you remember the concept of set theory. What does it say? If there is a universal set, which is the set of all these numbers 1 to 2000. So if I am writing all these numbers which are divisible by 3 here, so all the numbers which are divisible by 3 here, and all the numbers which are divisible by 7 here, so sir, there are going to be certain numbers which are going to be divisible by 3 and 7 both. Yes or no? So these numbers I'm supposed to exclude. These numbers I'm clearly supposed to exclude because they got counted twice. They were included when I was counting the divisible by 3. They got counted when I was counting the numbers divisible by 7. So they got counted twice. So I got to subtract them once. NA plus NB minus NA intersection B. That is NA union B. So that's exactly what I'm trying to say you here or suggest here. With that, let me find NA intersection B. So NA intersection means 3 as well as 7. So numbers which are divisible by both 3 and 7, which means the numbers which are divisible by 21. So that will be attained by GIF of 2000 divided by 21. Yes or no? So I hope that part you can easily do. Can I do it very quickly so that we don't waste our time here in calculating it? Although you can calculate it very easily by simply multiplying 21 by 100 or 10. And with that you can get this logic. But I am doing it 2000 divided by 21, that is 95 point something. So my answer here will be 95. So there are such 95 numbers which are divisible by this. But the question doesn't end here. It actually starts here. You have gotten the data now. Now after getting the data, what are you supposed to do next? That's the more interesting part here. Let's read the question again. P be the probability that the chosen number is a multiple of 3 or 7. So chosen number is a multiple of 3 or 7. So if it is a multiple of 3 or 7, it will be this plus this minus this, because 3 or 7, I hope you understand the meaning of the word or. So it will be 666 plus 285 minus 95. Yes or no? And this is the favorable cases. These are the favorable cases. So these favorable cases divided by the total number of cases. Sir, if you randomly choose a number, that's your event. So a number from these 2000 numbers can be chosen in 2000 C1 ways. So that's your 2000. And this whole value should be multiplied by 500 so that you can get the value P. So let me just do this. 666 plus 285 minus 95, although you could have done it very quickly. So it is 856. So I'm writing it here. It is 856 divided by 2000 whole multiplied by 500. So technically 500, 2000 is 4. So 856 when divided by 4 is what you're supposed to find out. That is 214. This value turns out to be as 214, and that's your final answer. That's your final answer. I hope you have understood all these questions. With this, I am giving you one question as a bonus question. Bonus question means this question I'm giving you as a homework question. So I was supposed to solve 5 questions, which I have done from JEE Advanced, which you could do with the 11th class logic. This is a question again, which can be done with 11th class logic. The short technique is there. By applying that, you can get this answer within 10 to 15 seconds. Mark my words, JEE Advanced question asked by 25 in 10 seconds. Mark my words. With this, I am moving ahead with this part that 5 questions of class 11th asked by JEE Advanced were done by us in this video. If you're preparing for Arjuna, if you're preparing for JEE in English and you're right now in 11th standard, then there is a batch called PW Arjuna JEE in English 2027. If you're in currently class 12th wanting to prepare for JEE in English, PW Laksh JEE in English 2027 is there. There you get structured notes. I hope you must have seen it. Will be taught by the top faculties of our country. And yes, you will be getting the DPPs with their video detailed solutions. Practice tests, regular tests will be conducted, and detailed analysis and feedback will be given to you. The story doesn't end here. There are a lot of benefits there, which you get by exploring our website pw.live or our channel. With that, I hope you have gotten a decent insight and clarity about what kind of preparation and how you should be preparing for this examination. Let's call it a day. Let's meet in some other video. We'll discuss more insights and more concerns and agendas of yours. Thank you so much. You have been a great audience.